Bluetooth Low Energy or Bluetooth LE, marketed as Bluetooth Smart, is a wireless personal area network technology designed and marketed by the Bluetooth Special Interest Group aimed at novel applications in the healthcare, fitness, security, and home entertainment industries. Compared to classic Bluetooth, Bluetooth Smart is intended to provide considerably reduced power consumption and cost while maintaining a similar communication range. Bluetooth Smart was originally introduced under the name Wibree by Nokia in 2006. It was merged into the main Bluetooth standard in 2010 with the adoption of the Bluetooth Core Specification version 4.0. Mobile operating systems including iOS, Android, Windows Phone and BlackBerry, as well as OS X, Linux, and Windows 8, natively support Bluetooth Smart. The Bluetooth SIG predicts more than 90% of Bluetooth-enabled smartphones will support Bluetooth Smart by 2018. Compatibility: Bluetooth Smart is not backward compatible with the previous, often called classic, Bluetooth protocol. The Bluetooth 4.0 specification permits devices to implement either or both of the LE and classic systems. Bluetooth Smart uses the same 2.4 GHz radio frequencies as classic Bluetooth, which allows dual-mode devices to share a single radio antenna. LE does, however, use a simpler modulation system. Bluetooth Smart branding: in 2011, the Bluetooth SIG announced the Bluetooth Smart logo scheme intended to clarify compatibility between low-energy devices. Bluetooth Smart Ready indicates a dual-mode device compatible with both classic and low-energy peripherals. Bluetooth Smart indicates a low-energy only device which requires either a Smart Ready or another smart device in order to function. Target market: the Bluetooth SIG identifies a number of markets for low-energy technology, particularly in the smart home, health, sport and fitness sectors. Cited advantages include low power requirements, operating for months or years on a button cell, small size and low cost, compatibility with a large installed base of mobile phones, tablets and computers. History: in 2001, researchers at Nokia determined various scenarios contemporary wireless technologies did not address. The company began developing a wireless technology adapted from the Bluetooth standard which would provide lower power usage and cost while minimizing its differences from Bluetooth technology. The results were published in 2004 using the name Bluetooth Low End extension. After further development with partners, for example, with an EU FP6 project Mimosa, the technology was released to the public in October 2006 with the brand name Wibree. After negotiations with Bluetooth SIG members, an agreement was reached in June 2007 to include Wibree in future Bluetooth specification as a Bluetooth ultra-low power technology, now known as Bluetooth Smart technology. Integration of Bluetooth Smart with version 4.0 of the core specification was completed in early 2010. The first smartphone to implement the 4.0 specification was the iPhone 4S, released in October 2011. A number of other manufacturers released Bluetooth Smart Ready devices in 2012. Applications: borrowing from the original Bluetooth specification, the Bluetooth SIG defines several profiles specifications for how a device works in a particular application for low-energy devices. Manufacturers are expected to implement the appropriate specifications for their device in order to ensure compatibility. A device may contain implementations of multiple profiles. All current low-energy application profiles are based on the generic attribute profile, or Gatt, a general specification for sending and receiving short pieces of data known as attributes over a low-energy link. Bluetooth 4.0 provides low power consumption with higher baud rates. In 2014 a Bluetooth Smart protocol with the name CSR Mesh was published. CSR is for Cambridge Silicon Radio. The protocol supports Internet of Things. For example, by QR codes it is possible to switch groups of, for example, CSR Mesh-equipped electronic light bulbs on or off, or individually. Healthcare profiles: there are many profiles for Bluetooth Smart devices in healthcare applications. The Continuo Health Alliance Consortium promotes these in cooperation with a Bluetooth SIG. HTP a Euro for medical temperature measurement devices. GLP a Euro for blood glucose monitors. BLP a Euro for blood pressure measurement. Sports and fitness profiles. Profiles for sporting and fitness accessories include HRP a Euro for devices which measure heart rate. CSCP a Euro for sensors attached to a bicycle or exercise bike to measure cadence and wheel speed. RSCP a Euro running speed and cadence profile. CPP a Euro cycling power profile. LNP a Euro location and navigation profile. Proximity sensing. Electronic leash applications are well suited to the long battery life possible for always-on devices. Manufacturers of iBeacon devices implement the appropriate specifications for their device to make use of proximity sensing capabilities supported by Apple-incorporated compatible iDevices. Relevant application profiles include FMP a Euro. The Find Me profile a Euro allows one device to issue an alert on a second misplaced device. PXP a Euro. The Proximity profile a Euro allows a proximity monitor to detect whether a proximity reporter is within a close range. Physical proximity can be estimated using the radio receiver's RSSI value, although this does not have absolute calibration of distances. Typically, an alarm may be sounded when the distance between the devices exceeds a set threshold. Alerts and time profiles. The phone alert status profile and alert notification profile allow a client device to receive notifications such as incoming call alerts from another device. The time profile allows current time and time zone information on a client device to be set from a server device, such as between a wristwatch and a mobile phone's network time. Implementation, chip. Starting in late 2009, Bluetooth Smart integrated circuit implementations were announced by a number of manufacturers. Implementations commonly use software radio, so updates to the specification can be accommodated through a firmware upgrade. Hardware. Current mobile devices are commonly released with hardware and software support for both classic Bluetooth and the Bluetooth Smart standard. The Bluetooth SIG maintains a list of devices. Operating systems. iOS 5 and later, Windows Phone 8.1, Windows Phone 8, Android 4.3 and later, BlackBerry 10, Linux 3.4 and later through BlueZ 5.0, Unison OS 5.2, Technical details, radio interface. Bluetooth Smart technology operates in the same spectrum range as classic Bluetooth technology, but uses a different set of channels. Instead of the classic Bluetooth 79 1 MHz channels, Bluetooth Smart has 42 MHz channels. Within a channel, data is transmitted using Gaussian frequency shift modulation, similar to classic Bluetooth's basic rate scheme. The bit rate is 1 bit s, and the maximum transmit power is 10 MW. Further details are given in Volume 6 Part A of the Bluetooth Core Specification v4.0. Bluetooth Smart uses frequency hopping to counteract narrow-band interference problems. Classic Bluetooth also uses frequency hopping, but the details are different. As a result, while both FCC and ETSI classify Bluetooth technology as an FHSS scheme, Bluetooth Smart is classified as a system using digital modulation techniques or a direct sequence spread spectrum. More technical details may be obtained from official specification as published by the Bluetooth SIG. Note that power consumption is not part of the Bluetooth specification. Software model. All Bluetooth Smart devices use the generic attribute profile. The application programming interface offered by a Bluetooth Smart Aware operating system will typically be based around Gatt concepts. Gatt has the following terminology: client, a device that initiates Gatt commands and requests, and accepts responses, for example a computer or smartphone. Server, a device that receives Gatt commands and requests, and returns responses, for example a temperature sensor. Characteristic, a data value transferred between client and server, for example the current battery voltage. Service, a collection of related characteristics, which operate together to perform a particular function. For instance, The health thermometer service includes characteristics for a temperature measurement value, and a time interval between measurements. Descriptor: a descriptor provides additional information about a characteristic. For instance, a temperature value characteristic may have an indication of its units, and the maximum and minimum values which the sensor can measure. Descriptors are optional. Each characteristic can have any number of descriptors. Some service and characteristic values are used for administrative purposes. For instance, the model name and serial number can be read as standard characteristics within the generic access service. Services may also include other services as sub-functions. The main functions of the device are so-called primary services, and the auxiliary functions they refer to as secondary services. Identifiers, services, characteristics, and descriptors are collectively referred to as attributes, and identified by UUIDs. Any implementer may pick a random or pseudo-random UUID for proprietary uses, but the Bluetooth SIG have reserved a range of UUIDs for standard attributes. For efficiency, these identifiers are represented as 16-bit or 32-bit values in the protocol, rather than the 128 bits required for a full UUID. For example, the Device Information Service has the shortcode 0x180A, rather than 0000180A1000. The full list is kept in the Bluetooth Assign Numbers document online. Gatt operations. The Gatt protocol provides a number of commands for the client to discover information about the server. These include: discover UUIDs for all primary services, find a service with a given UUID, find secondary services for a given primary service, discover all characteristics for a given service, find characteristics matching a given UUID, read all descriptors for a particular characteristic. Commands are also provided to read and write the values of characteristics. A value may be read either by specifying the characteristic's UUID, or by a handle value. Write operations always identify the characteristic by handle, but have a choice of whether or not a response from the server is required. Long read and long write operations can be used when the length of the characteristics data exceeds the MTU of the radio link. Finally, Gatt offers notifications and indications. The client may request a notification for a particular characteristic from the server. The server can then send the value to the client whenever it becomes available. For instance, a temperature sensor server may notify its client every time it takes a measurement. This avoids the need for the client to poll the server, which would require the server's radio circuitry to be constantly operational. An indication is similar to a notification, except that it requires a response from the client, as confirmation that it has received the message. Further reading: Gatt is described in full in Volume 3, Part G of the Bluetooth 4.0 Core Specification. See also, ANT and ANT+, DASH7, IEEE 802.15/IEEE 802.15.4-2006, iBeacon, Indoor Positioning System, Myriad, Ultra-Wideband, UWB Forum, WiMedia Alliance, Wireless HD, Wireless USB, Zigbee, Z-Wave. References. External links: How Stuff Works, Bluetooth Low Energy Profiles Explained, Getting Started, Find My Car Smarter uses Bluetooth Smart to locate your car.